Welcome back to Calendar Examples, and in this tutorial we are going to do a linear material and a non-linear material simulation for a Belleville washer, and we are going to run the simulation in Ansys Workbench 2021 R2. We already have our geometry provided, so if you check the link in the description you will have access to such. So let us begin our simulation. Firstly, once Ansys Workbench is opened, you can hover over to your Analyst System toolbox and you need to drag a static structure into our project. And now that has been added to our project, let's click on geometry. Now let's right click on geometry and let's import our geometry. You can browse for the geometry where you downloaded it or where you have it stored, and I won't do that because I already have it here. So I'll click on it. Now that it has been loaded, I'm going to double click on model to start our mechanical. So our mechanical is finished loading, so let us start to set up our simulation for our linear material. So first, let's click on surface body. We're going to scroll down, and as you can see, we need a thickness. So let's enter 1, and we want to ensure that our material, let's go down to material. Our material is structural steel, so that is good. And now let's ensure, before we continue or go any further, let's ensure that our units is set to metric millimeter, kg, newtons, seconds, etc. So you can access that on your lower right hand corner of your screen, or you can access it from home and then from your units. Okay, so let us continue. Now let us set up our Analyst Settings, and here we want the number of steps to be 2, and also we need to turn on large deflection. So let's ensure large deflection is on. Okay. Now let us apply some boundary conditions. So now let's right click on Analyst Settings and let's insert displacement, and we need to select an edge. So our first edge is this one. To ensure that you select an edge, you can change your settings to select edge selection, or you can use Ctrl E on a keyboard. So it's easy to select edges, as you can see. So we need to select this edge as our first edge, and you need to click apply in your details toolbox, or detail ribbon, or whatever you want to call this, palette, whatever. And you want to change our Y component to 0. So only the Y component is being manipulated, and of course we need to select our geometry, which we selected this edge. Now we want to repeat the process. I'm going to right click on Analyst Settings and then insert another displacement. So that is displacement 2, and this time we're going to select this edge and we're going to click apply. But now our Y component has to be tabular data. So we're going to click on the arrow, and there is tabular. So we select that, and now we have the option of a tabular data. Everything else remains the same. With displacement 2 still selected, we now need to make some changes to our tabular data. So let us change our second step. As you see, second step, let's change this to -1, and we're going to change this to 0, the third step to 0. Now let us continue. Before we do that, let us rotate our model a little bit. So you can use the middle mouse button, and let us rotate, and when our Z is a little bit upward, as you can see here, just click your Y, and now we have our geometry more front on, and you can hit zoom to fit to bring a center, and then you can just zoom out a little bit. And now that our geometry is in a more front on and better view, let us insert some more forces. So now let us right click on solution. So first we highlight solution and right click, insert, and we're going to insert stress, and we're going to insert an equivalent Van Mises stress. Okay, and once we have that inserted, we're going to click on solve. Now that our first computation is finished, if we click on our equivalent stress, and we have our tabular data and our graph. So now let us, if we click on our first sub-step and we right click, we need to retrieve the results, and you will have a warning telling you about large deformation, but that's okay because that's what we are using to run our simulation. And you can now see that you have your maximum, your minimum values, and we now need to insert some coordinates. So if we click on our coordinate system in our project window, okay, we now have the option to insert a new coordinate system. So we can go to our ribbon. So as you can see, once you click coordinate system, it carries you to a ribbon where you can add a coordinate system. And once we have that selected, we want to rename it. This is our new coordinate system. Let's rename it to cylindrical coordinate system. So you can press F2 on your keyboard. Once you highlight it, you can press F2 on your keyboard and type cylindrical coordinate system. Now that we renamed our coordinate system, we need to make some changes. So firstly, for type, we're going to change it to cylindrical and define by, we're not going to define by geometry, we're going to define by global coordinates. Let me bring this out a little bit more. So yes, defined by global coordinates. And we're going to make sure all of our settings is okay. So origin X 0, origin Y 0, origin Z 0, and our axis is X, and global X axis for this is for principal axis. And for orientation about principal axis, here we're going to change from Y to Z. So let me bring this up a little bit more. Also, we need to change define by, that's under orientation about principal axis. We need to change that to global Y axis. Okay, and let's scroll down. So here are our settings for our cylindrical coordinate system. And now we need to insert a normal stress. So let's right click on solutions, insert, stress, normal, and we're going to make some slight changes. So let's scroll along to time display. We need to make that 1 second. Our orientation need to be about the y-axis, and our coordinate system need to be our recent coordinate system that we set up, the cylindrical coordinate system. And now we can run our simulation. And we have a warning about geological deformation. That is okay. Now that we have our data for our normal stress, you can analyze your data. Also, you can go to solution information, and if you click solution output and you go down to force conversions, you can see we have more information about our simulation, and also we have our graph and our tabular data for both normal stress and equivalent stress. So you can explore with these a little bit more, but let us now insert a probe, which is from the probe we're going to insert a force reaction, and we want to do this in order to know the force required to displace the Belleville spring. And how do we do that? We need to highlight solution. We can right click, insert. Let's go down to probe, and we're going to insert a force reaction, and we need to input some settings. Earlier we set up some displacement, so now our boundary condition is going to be displacement 2, which is this one. And also we need to check our axis. So for options, on the options where I have result selection, we're going to change that from all to y-axis, and those are our two changes. After we set up our force reaction, we need to click solve, and here are our results, force reaction results. It seems pretty good, and we need to set up more load steps, so we need to do 2 load steps. Now how do we do that? Let us highlight Analyst Settings, and under Analyst Settings we have number of steps 2, so our current step will be 1. Okay, time end step is 1 second. Auto time step, we need to take that off. Auto time step in, take it off. Defined by time. Okay, time step 0.1 second, and everything else is default. Make sure large deformation is still on. And now we want to click solve to run our simulation. And we have a warning, but it's okay. And now that our simulation is finished, we need to repeat the process. So now we need to do the second step, the second load step. So here we need to input 2 for current step number, and this time we're going to change step end to 2 seconds. Okay, and at the time step in, make sure that it's off, defined by time, and time step 0.1 second, and large deformation must be on. Everything else remained as is, and this is for our second load step, and we need to solve. So ignore the warning, it's okay, just a warning, not an error. And now let us check our results. So if we go back to solution information, here is our results, and also more importantly, if we go to force reaction, select force reaction, we have our data. So I can bring this up a little bit bigger, and you can see that we have our curve, one for our first load step and another for our second load step. So the first one was for 1 second, the second one for 2 seconds. Okay, now we need to add some user-defined results. So let's highlight solution, and if we right click on solution, we have insert, and if you notice to the bottom we have the option to insert a user-defined result. So let us go ahead and click on that, and in our user-defined result settings, we need to change from all bodies to edge. So let's select this edge and apply, and for expression should be capital UI. Okay, and click outside. So you should have equal UI, and this is our units. Everything else remains default. So that is the two changes: geometry, this one, this edge, and expression to UI. And now we want to solve. Now if we click on user define, we have our results, and as you can see here, this is our displacement versus time curve, and here is our data, or tabular data. Now let us set up a force versus displacement curve. So what we need to do is click on our solution, and now we have the option to insert a chart. Okay, so what I'm going to do before I select the chart is I'm going to highlight force, because it's a force versus displacement. So our force, I'm going to highlight force, and then I'm going to hold Control on my keyboard, and then I'm going to select user defined result. So with these two values selected, I'm now going to click on chart, and therefore we have outline selection to objects. Okay, so our x-axis, we're going to use our user defined maximum. Plot style both scale, linear, guidelines none, and our labels, our x-axis, you can type displacement, and our y-axis, we can type force. Okay, and our content is okay, and for time we're gonna select omit, and for user defined minimum we're gonna omit as well. And this is our chart and our table, our tabular data. Can bring it up a little bigger to view it more clearly. So this wraps up our simulation for the linear material. So next we are going to run a simulation for a nonlinear material. Now that we have finished our linear material simulation, let's close mechanical. Now let us set up our project schematic for our nonlinear simulation. So let's duplicate our first one. Now our second setup is being loaded. Let's rename them. So you can simply right click and you can rename. and this one you can use Control A, backspace, and this one we call Belleville washer linear material. And this one, we're going to repeat the same process. Right click, rename, backspace, and let us rename this one to Belleville washer non-linear material. Now that we have finished renaming our setup, let us double click on the engineering data for our Belleville washer non-linear material, and here we are going to add some elements to our material elements to our settings. But before we do that, let us let us check our units, and we're going to make sure that our units are set to metric, ton, millimeter, seconds, etc. Let's go back here, and our display value should be in project units and not as defined. Okay, so metric ton, display values and project units. And now let's expand plasticity. So if it's closed, you can expand it, and we're going to double click on multilinear isotropic hardening, and that is now added to our properties. And with that done, we are going to select tabular, and we're going to highlight under table of properties row 12 multilinear isotropic hardening. We're going to highlight this, and you're going to input 22 degrees Celsius, and we're going to input some data. So you can copy the data that I'm going to input. So you can go ahead and input this data. So it's a plastic strain, and here's our plastic strain curve. So you can pause the video here and input these data. Now let's go back to our project. So we can do so by clicking project next to engineering data, and double click on model to open mechanical. And would you like to read upstream data? You can click yes and continue. So mechanical takes a while to load. So now that mechanical has been loaded, let us highlight solution information, and we are gonna click on solve. So you can ignore this warning, and here is our force conversion curves. That seems quite accurate. And let's now go back to our non-linear simulation results. So let's view our other results. So if we highlight equivalent stress, we can take this up a little bit more, and we can analyze our data. And you can do the same for normal stress. And you can analyze and assess your data. And if you want, you can do the same for force reaction just to see what it looks like. Okay, so let's go back to normal stress. And let's go to our chart. So let's go down to equivalent stress, and at 14th value we need to retrieve this results. So you're going to right click on that, retrieve this results. Now we are going to repeat the same process for our normal stress. So we'll go down to our 14th data, 1.4 seconds. We're going to right click and retrieve this data. And we have a warning, ignore the warning. Now that we have retrieved our results, if you use a middle mouse button and just rotate your model a little bit and analyze it, you can see on the top surface we have a lot of tension, and on the bottom surface we have a lot of compression. So you can analyze your data and write your report, whatever you need to do regarding this simulation. Thank you for tuning in to another tutorial with Cabinda examples, and remember, everything that you do it well. Bye for now.